Hello everyone, this is Snigdha Kakkar and this is my channel Accelerate AI Careers. Today we are going to solve LeetCode 55 jump game. It's a very interesting problem, a medium level problem on LeetCode. It has been asked by Amazon and Google in the last 6 to 12 months. Let's look into the question first. So you have been given an array of positive integers, nums, and you are initially positioned as the beginning of the array at the first index of the array. And each element in the array represents how much maximum jump length you can take from that position. So you have to return true if you can reach the last index starting from the 0th index, or false otherwise. So let's look at some examples first, and then we will see what are the approaches we can use to solve the question. So let's look at first example. Here the nums array is 2, 3, 1, 1, 4. And if you see from index 0, you can take either 1 jump or 2 jumps. So if you take 1 jump, you reach index 1. And here you can take 3 jumps. So if you take maximum of 3 jumps, you directly reach the last index. Hence, you can reach at the last index starting from the 0th index. Thus, your output is true. Similarly, let's look at example 2. The example 2 is 3, 2, 1, 0, 4. So if you see that if you start from 0th index, the maximum jump you can take is 3. Say suppose I take the maximum jump. So you reach index 3. Here the number of jumps you can take is 0. So that means you are locked here. It's a dead end. So you cannot go anywhere. Say suppose from 0th index I don't take 3 jumps, I take 2 jumps. If I take 2 jumps, I reach the second index where I can take maximum of 1 jump, and again I'm locked at index 3 and I cannot go further. Suppose I do not take 2 jumps from index 0, I take 1 jump. If I take 1 jump, I reach index 1. And here I can take maximum of 2 jumps, where I will reach index 3 and I get locked again. Hence, there is no way I can reach the last index. Hence, the output is false. This is the crux of the question. Now, let's look at the approaches which we can use to solve this question. Now, what would be the brute force approach to solve this question? Say suppose the second example 3, 2, 1, 0, 4. Let me number the indices. So the indices would be 0, 1, 2, 3, 4 here, as you can see. And how will we try to solve it? Like I just explained, I will take the 0th index and then I will force all the solutions which I can take. Either I can do 1 jump, or I can make 2 jumps, or I can make 3 jumps at max, because the letter first here at 0th index is 3, right? So if I make 1 jump, then I reach index 1. If I make 2 jumps, then I reach index 2. If I make 3 jumps, then I reach index 3. Now, if I reach index 3, there are 0 jumps allowed. That means that's a dead end, and hence I've marked the dead end here. If I take 2 jumps and reach index 2, then I can take only 1 jump, because it's mentioned here 1, right? So if I take only 1 jump here, then I reach index 3, which is a dead end, right? If I'm at index 1, then I can either make 1 jump or 2 jump, and I will reach index 2 or 3 consequently, and both are actually dead ends. That means I will look at each indices and what kind of jumps I can make, and I will take all those choices and reach the next indices and see if I can go further. If I by chance reach the last index, then I return true. If I don't reach the last index and there are dead ends, then I return false. So if the length of the array is n, then looking at all the n choices, and then we are looking at n choices for each of the choice. So if I reach index 1, then for index 1, I'm looking at the n choices. And for index 2, I'm looking at the n choices. So the time complexity, if we do not use any memory, we just go ahead with the brute force approach, it would be O of n raised to power n. Now, if we consider cache, then we can reduce this time complexity by using additional memory, additional storage, and we can reduce it to O of n square. How do we do that? So as you can see, when we tried 3 jumps from index 0, reached in index 3, we saw that it's a dead end, right? So we can already record dp of 3 is false, that you cannot reach the last index from 3rd index. Now when you look at other choices, say you are looking at this and you go from index 2 onwards to index 3, you don't need to go any further. You already know dp of 3 is false. Similarly, here you have already checked if dp of 3 is false and you are not reaching from index 2 to last index 4. So dp of 2 is also false. So you can save that. And once you know dp of 2 is false, you don't need to go ahead in the entire loop. And if you know you reach index 2 and from index 2 dp2 is false. Same way, if you do not reach from dp2, You can mark dp1 also as false, because from 1 either you can go to index 2 or index 3. Both are dead ends, so dp1 is also false. And then same way you can finally rewrite dp0 is false. So you can cache all that, and with that you can reduce the time complexity to O of n square. But is there a better approach? Can we even reduce the time complexity more than this? So yes, there is a linear time complexity approach, O of n, and we will look at how do we solve it. It will be using greedy method there. Now let's look at the ON time complexity approach, and we'll not be using any additional memory. So say suppose we take example 1 where the array was 2, 3, 1, 1, 4, and we number all the indices. So instead of starting from 0th index and reaching the last index and checking all the choices, what we can do is we can do reverse. Start from the last index, take it as a goal. So this arrow shows it as a goal post, and see if you can reach the 0th index from this goal post. And how you can see it? So like from this array, you can look at index 3 to index 4. If index 3 you look at, there is maximum 1 jump allowed. So with 1 jump, you can reach index 4 from index 3, right? So yes, this can work. So we move goalpost from index 4 to index 3. Because now we know that we can definitely reach from index 3 to index 4. So we may move our goalpost from index 4 to index 3, that if we are able to manage to reach to index 3, we'll surely be able to reach the end of the array. So now let's look at index 2 to 3. So index 2 allows maximum 1 jump. That means you can at least reach index 3 using 1 jump, that 1 jump from index 2. And we already know that we can reach the end of the array if we are at index 3. So we can move the goalpost from index 3 to index 2 as shown here. Now let's look at index 1 and see if we can reach at least index 2. So index 1 has maximum of 3 jumps allowed. So at least we can take 1 jump and move to index 2, and we already know that from index 2 we can reach the last of the array. So hence we can move the goalpost from 2 to first index. Now we are at first index. Now we need to just check if it is possible to go to first index from 0th index. And 0th index indicates that maximum of 2 jumps are allowed. That means we can at least take 1 jump and reach index 1. And from index 1, we already know that we can reach the end of the array. And hence we can conclude, yes, we can reach the end of the array starting from index 0. So instead of going from 0th index to last index and checking all the choices, we can go from last index to the 0th index and move the goalpost accordingly. And if we are able to reach index 0 that way, that is our goal is equivalent to 0th index, that means yes, the path is possible and we can mark and return true. If we do not reach at 0th index and get stuck somewhere, then we can return false. I hope the approach is clear to you. Now we'll start coding. The code is very simple for this particular question. Only thing was understanding that you need to start from the end and not from the beginning. Now how do we start from the end? We estimate a goal. The goal would be initialized from the last of the array, that is length of nums minus 1, that is the index. We initialize the goal from. Now we apply a reverse loop. So we start from index last and reduce it by 1 for I in range, length of nums minus 1, and reduce it by minus 1 until you reach 0th index. So that's how you'll apply the reverse loop in Python. And what do you check? If the current index, which is I, plus the number of jumps allowed at this index is nums of I, is greater than equal to goal. That means you can at least reach that goal, right? So you update the goal with I. So basically, if you can take the jumps to reach the goal, then you move the goal to the current index. So if I plus number of jumps allowed, that is nums I, is greater than equal to goal, then move the goal to current index. And that you do till you reach the final of the loop. And if you reach the 0th index, that is goal is equal to 0, that means you can forge the path from 0th index to last index. And if it is not equal to 0 and gets stuck somewhere in between and is greater than 0, then you return false. So return true if goal is equal to 0, that is you have reached the 0th index starting from the last index, else return false. So this is the entire code, and you're not using any additional memory, you're not using any cache, and it's just a linear time complexity code. I hope the solution is clear to you. If you know any better approach to solve this, let me know in the comments. I will be explaining Jump Game 2 next. So subscribe to my channel to stay tuned and get your updates for daily LeetCode challenge. Let's see and run if this works. So yeah, like our solution is working fine. Thank you.